Hello everyone, welcome to my online class. Today we will start kinematics lecture number 3. But before going to start this lecture number 3, let me first discuss the questions that I have given you as homework from kinematics lecture number 2. So let's see what were those questions and try to solve those questions. Okay, so here it's the first question. I think that we could solve this question in our class only. I have solved this question in my class also. Let's try to solve this one. So this question says find the VTST graph with equation, and if a t graph is given in your question and the initial velocity is given 10 meter per second and initial position is minus 2 meter, and also find the time interval when speed decreases. Let us first plot the AT graph that is given in my question. So it is question number 3. Let us first plot the AT graph that is given. As you can see, I have drawn AT graph, and below that I have taken my VT coordinates, and just below that I have taken my ST or position time coordinates. And to maintain the time frame equal, I have drawn these vertical yellow lines. So this vertical line represents the 10-second time frame, it is 20-second, and this is 30-second, and it is the origin. So the first I need to plot the VT graph. So from 0 to 10 second, what will be the equation for V? You can see its initial is 10 meter per second and acceleration is negative minus 2 meter per second square. So from 0 to 10 second, the velocity function will be v equal to u, that is 10 minus 2t. So that is our equation of straight line starting from 10, as the y-intercept is 10 and its slope is minus 2, right? So 10 minus 2t, let us plot this graph. It will start from here at plus 10, and after 10 seconds it will go to minus 10, right? So I hope that you could draw this graph and you can match my graph with yours. It is plus 10 and this is minus 10. Now from 10 to 20, as acceleration is 0, so the velocity will remain constant at minus 10 only. And from 20 to 30, again as acceleration is plus 2, so it will be the similar graph, but now the slope will be just positive plus 2. So this graph will be like this, where this value will be again, this value will be again plus 10 meter per second. So that will be the VT graph. I hope you could solve this VT graph easily. Now let us try to plot the position time function. So from t equal to 0 to 10 second, you can see that initial position is given as minus 2, and initial velocity I will take u1, initial velocity will be plus 10, and acceleration is given as minus 2. So my equation for position will be s equal to s naught plus ut plus half a t square, So that equation becomes minus 2 plus 10t minus t square. As you can see, it is a parabolic equation. So how do I plot the parabola? For that I will first say what is a. A is negative, so my parabola will open downward like this. Then I will check what is this symmetric line. It's minus b by 2a, minus 10 by 2 into minus 1. So it is 5. So 5 line is the symmetric line, and y is equal to minus 2 will be the starting point of this graph. And whether this graph cuts the x-axis or not, for that I will find the discriminant. So discriminant is equal to minus b plus minus root over of sorry, discriminant is only b square minus 4ac. So discriminant is equal to b square minus 4ac, 100 minus of 4 into a into c is plus 2. So as it is positive, discriminant is positive, so it will cut the x-axis. It will cut the x-axis, right, like this. So as I start from here, also you can see one thing, that where the velocity is zero, definitely position time graph will have a maxima or minima at that point. As you can see that the symmetric line definitely will lie where the velocity is zero. So here, as the velocity is zero here, and the graph will start from here, -2. Graph will start from -2. So my graph should look like this. My graph should look like this, right? As it is symmetrical, so this point is also at -2, right? This point is also at -2 meter. And what is this maximum height that you can find? This maximum height you can find by calculation by putting t equal to 5. Actually this is t equal to 5 second, right? At t equal to 5 second, so 50 minus 2, that is 48, and again minus 25. 48 minus 25 is 23, I think. So 23 meter will be the highest point. So the equation of this parabola is this one. Now in between t equal to 10 to 20 second, 10 to 20 second. Now what is the initial position? Initial position, I will take this position to be the initial position now, this position, right? -2. So s naught is equal to -2 now. What is initial velocity or the final velocity? All of them are constant. It is -10, you can assume -10, because it is a constant velocity. So the s function will be s naught plus ut minus 10t, right? That will be the function for s. But here one thing you should note, that if you put t equal to 0, if you put, sorry, t equal to 10, if you put t equal to 10 second, you should find 2 minus 2, because at t equal to 10 second the displacement or the position is actually -2. But from this equation you cannot find this position. You should understand what is the modification needed in this equation. I have taken this as my s-axis and this as my t-axis when I study from 10 to 20 second. I am studying from 10 second to 20 second actually, right? So my time axis starts from here. So according to this equation, your time is 0 equal to here. According to this equation, you have taken time 0 here, but your original time is here, right? So how do I get this original time from this time? You can say it is t prime, right? Because from here you have taken t prime. You can see when t prime is 0, the original time is 10. When t prime is 0, the original time is 10. So can I write this as -2 minus 10 of original time t minus 10? Because when original time is 10, your t prime should be 0. Here you can check. If you put t equal to 10 now, then you will find s equal to -2, right? So this is a actual concept of the shift of reference frame. I have shifted my time axis from here to here, right? So as I have shifted my, not time axis but s axis, I have shifted my s axis from here to here by the amount 10 second. So I have to subtract the time equation. I have to subtract 10 from the time equation that I will get now. Now you will find a straight line equation. It is a straight line equation. How do I plot this straight line equation? It is simply this one, right? Now you can see that I have plotted that straight line, keeping in mind that at this point the parabola and the straight line must have a common slope, because velocity can be found by taking the tangent and finding its slope at any point, and one point cannot have two velocities, right? So that is why I could draw a tangent at this point, and I can actually extend the same straight line. So this will be your equation of motion for t equal to 10 to 20 seconds, right? This will be your equation of motion. This will be your equation of motion for t equal to 0 to 10 seconds. Now let us come to the last part. Again, you can see that for the last part, at this point, this line will represent the symmetric line of the function, because here velocity is 0. So the graph will have a maxima or minima at this point, right? Before calculating the last graph, let us first calculate what is this position. What is this position at this point? To find this position, I will put t equal to 20 in this equation. If you put t equal to 20 in this equation, so 20 minus 10 is 10. So 10 into 10, 100, and it will be minus 102. Why I have calculated this? Because for the last part of the equation, you need this minus 102 as to be the initial position. We will use this minus 102 as my initial position. Let us find the equation first. For last part, for t equal to 20 to 30 second, t equal to 20 to 30 second, we can have s naught equal to minus 102. We can have initial velocity. What is initial velocity? It is minus 10, and acceleration is equal to plus 2. So my equation should be s equal to s naught plus ut plus half a t square. Half a t square, half and 2 gets cancelled out. But again, as you can see that I have written this equation assuming my s-axis shifted from here to here. So how much I have shifted my x-axis? By 20 unit. So my time should be here, if I say it is t double prime, then to go back to the original time frame, I have to subtract 20 from this time frame, right? Because what is 20 in this time, what is 20 in original time frame is 0 in this time frame actually. So what is s? Equal to minus 102 minus 10 into this is t minus 20 and plus t minus 20 whole square. So that should be the actual equation of motion for the third part. But I can plot the equation by assuming this as my s-axis, this is my t-axis, and using this one equation. So that is starting from minus 102. So its y-intercept is minus 102. And as a is positive with t square, you can say a is positive. So the graph, parabolic graph, will look like this. I know that symmetric line is here. So it is pretty simple to plot the parabola. This parabola will look like this. Right? This parabola will look like this. I hope that completes the graph. And if you have understood this, it's very good. And if you have actually you have to understand the solution of the equations, right? If you put the value of the time, you should find the same position that you are expressing in your graph. Let's move to our next question. It says a particle is chasing another particle and both of them are moving in the same direction. Their motions are described in the following velocity time graph. Find the time when the chase will end. Okay. So as you try to solve this question, first let me draw the VT graph that is given, and we will use a simple concept that area under VT graph gives you the displacement, right? Area under VT graph gives you the displacement. So that is time, this is velocity. If I drop a perpendicular from here to here, this is 4, this is 3. Suppose the chase ends here, right? Suppose the chase ends here at this point. So what I can say, that the area under this triangle, let us name them ABC, area under this triangle ABC is equal to area under this triangle O, say D and C, right? So these two areas should be the same. That we have to find what are the area of this graph, right? So let us assume that this one is V, right? This one is V. So what is the area under this graph? If you can see that from this triangle, small triangle, let us assume this one is U. This one is U, right? So if this one is U, can you see from this triangle and this triangle, these are similar triangle. Let us name them E. So the triangles are similar. Which triangles? Triangle B, E, and say F. B, E, and F. This triangle similar to the triangle B, A, and C, right? So in this case, I can say that U divided by 1, this is U, this is 1, is equal to AC, that is V, divided by, say this time is, suppose this time is T, so it is T minus 3, right? So this is the first equation that I can write. Similarly, for this graph, if I say that this velocity is, say, V prime, I can have two similar triangles here also. Triangle OEF similar to triangle ODC. What I can say that U divided by 4 is equal to V prime and divided by T. Okay, this is the second equation. And the area of the triangles are same. So I can say half into V into T minus 3, that should be equal to the half into V prime into T. So if I replace V from this equation, it will be U into T minus 3. There is another T minus 3, so that will be squared. And if I replace V prime, so it will be U into T by 4. And there is another T. So U gets also cancelled out. So for your equation, I can solve that T minus 3 is equal to T by 2. If I square them up, then you will find that time is equal to 6 seconds. That should be the answer of your question. So let's see what do we have in the next question. I hope that this question we have done in our class. I will skip that. Now this question. The figure shows the Vt graph of a particle moving in a straight line. Find the time when particle returns to the starting point. So let us try to solve this question by again assuming the same concept, that area under Vt graph gives you the displacement. So let us try to solve this one. First draw the graph given. This is V and this is time axis. This is the graph that I can plot, right? Okay, so this is V, this is T. It is given that this velocity is 20 meter per second, and this time is 20, and this time is 25. So when the particle returns to the starting point, you can see that when the particle will return to the starting point, its displacement should be 0. And displacement is nothing but the area under the graph. How do I find area under the graph? If you find area under the graph, then you can say that suppose this time is t, then you can see that this, when you find the area, I will take this to be my positive area and this to be my negative area. So if these two area actually matches with their magnitude, then I can cancel each other, then I can say that this displacement is 0. What is the area of this first triangle? Let us suppose it is A and the second triangle is B. So what is the area of A? I can say area A is equal to half into 25 into 20, right? So that is equal to 250 units, right? Square units. Area is equal to 250. Now it is the same thing I can find for the area B. The area B will be equal to this half into t minus 25 multiplied by this height, right? By this height. Now how do I find this height that I have to find? Suppose this height is h. How do I find this height? You can see that if this angle is theta, this angle is also theta. And what is tan theta? Tan theta is equal to from this triangle is h by 20 minus 25. But from this triangle, I can say tan theta is equal to 20 divided by 5. Tan theta is equal to 20 divided by 5, right? From this triangle, as this height is 20 and this much distance is base is 5, right? So 20 by 5 is 4. So I can say that h is nothing but 4 into t minus 25. So this is equal to half into t minus 25 square multiplied by 4. So that should be equal to 250, as the area should be the same. Let's see what do we have in our next question. It says a train takes 2 minutes to acquire its full speed 60 km per hour from rest and 1 minute to come to rest from the full speed. If somewhere in between the two stations 1 kilometer of the track be under repair and the limited speed on the part to be fixed 20 km per hour, find the late running of the train on the account of the repair work, assuming otherwise normal at running of the train in between the stations. Okay, so to solve this question, let me first draw how the VT graph of the train will look like in its normal day. When there is no repairing work, how its VT graph does look like. Suppose this is the V axis, this is the time axis. So it says that it first accelerates such that it have 60 km per hour velocity in 2 minutes of time, right? So it accelerates, then it moves with 60 km per hour as usual, and after that it comes to rest with some deceleration. So this is a typical VT graph for a normal journey day of the train. You can see that this velocity is maximum 60 km per hour. Let me put it in minutes. So it will be 1 km per minute, right? V is in kilometer per minute because the time units are in minute. So I have taken it in minute. And in 2 minutes, it assumes this 1 km per minute. So this is t equal to 2 seconds, right? So you can say that its acceleration for this time is equal to, its acceleration is nothing but the slope, that is equal to 1 by 2 kilometer per minute square. That is the acceleration of the train for 0 to 2 seconds. Again, this is 60 or 1 kilometer per minute, and from here to here the train again decelerates, and you can say that this time is 1 second, this time is 1 minute, this time is 1 minute, and in 1 minute time its speed decreases from 1 kilometer per hour to 0. So the deceleration part says B is also 1 kilometer per minute square. Deceleration is 1 kilometer per minute square because this length is 1, this length is 1, so slope of this line is 1. So it is a normal day. What happens in a day when there is repairing work going on? So suppose at this point the velocity has to be reduced by 1/3, means 60 km per hour. Now the velocity is 20 km per hour, so it has to be reduced by 1/3, right? So how it can be reduced? It can only be reduced if the train starts decreasing its velocity from here at this point and maintain the same slope as the retardation, right? Because its retardation is a constant, so it has to retard from here, so that when it comes here its velocity remains the same up to 1 kilometer, and that is 1/3, means 1 by 3 kilometer per minute. So after 1 kilometer is over, not after 1 kilometer is over, then the train again So after 1 kilometer is over, the train can again accelerate. Now the acceleration slope should remain the same as the original acceleration, and it comes here and again it moves with 60 kilometer per hour, and then it is the normal motion of the train. So you can see that this graph is actually the graph on a repairing day. What I have to understand that on a repairing day, when the train moves in this way, actually this much distance it has to cover later on. What I am trying to say, that when the train was running normal with say 1 kilometer per minute, this distance was covered with 1 kilometer per minute. But now, due to this repairing work, the train has to move down and go like this. So as the area under VT graph gives you the total displacement, so now the total displacement you will find this much, but the distance between the stations remain the same. So the train has to manage this much distance after moving this 1 kilometer, right? So after moving this 1 kilometer, the train has to manage this much distance, right? And this much distance it will move with 60 kilometer per hour or 1 kilometer per minute, right? So if I say that what is this much distance left out, then I can find that what is the delay of the running of the train. I hope you can understand what I am trying to say. So this is 1 by 3. This line is 1 by 3 kilometer per minute, right? And you can see that we will now calculate this part easily. If I drop a perpendicular to this one, and if I drop a perpendicular to this one, right? So as this is the 1 kilometer only it covers with 1/3 kilometer per minute. So this time interval is 3 minutes only. This time interval is 3 minutes, right? This is 3 minutes. Now it is 1 and it is 1 by 3, right? So what is this much? You can say that it is 2 by 3, right? 1 minus 1 by 3. This is also 2 by 3. Now the slopes are same. That slope is half, right? So that slope is half. So if it is 2 by 3, this distance must be 4 by 3, double of that. This distance must be 4 by 3, and this slope is 1, so if it is 2 by 3, it is 2 by 3, right? So this entire distance, this entire time is actually 3 plus 4 by 3 plus 2 by 3, that means 5. So this time is 5 minutes, right? So from 5 minutes, if I calculate this total area of the rectangle, I am talking about the area of the rectangle, area of the rectangle, area of a rectangle, that is 5 into 2 by 3, that is 10 by 3 kilometer. From there I will subtract these two small triangles, right? Area of triangles is half into 2/3 into 2/3 plus half into 2/3 into 4/3, right? So that is equal to half into 2/3 into 2, so that is nothing but 2/3. So area of the triangles is 2/3. So what is the shaded area that the train has to cover after covering this 1 kilometer? So this area is 10 by 3 minus 2 by 3, so that is 8 by 3 kilometer. That kilometer the train has to cover with a with a velocity of 1 kilometer per minute, right? So what is the time delay? I can say it is 8 by 3 minute only. 8 by 3 minutes, that is 8 by 3 into 60 second. So 160 second should be the answer of this question. Now in solving this question, we have assumed that the road that was under repair lies in between the points where the train usually move with 60 km per hour. But it is not mentioned in your question. It should mention in your question. Otherwise, anyone can assume this type of situation also. That suppose when the train starts, it moves from 0 to 20 kilometer per hour. As soon as it moves at 20 kilometer per hour, it sees that there is a road under repair. So the train remains its speed with 20 kilometer per hour only. After 1 kilometer is over, then again it accelerates like this and reaches at that point, and then again it decelerates to uh, uh, end its journey, right? So in that case, if you try to find, then the calculation is a bit difficult. I hope you can understand the situation what I am trying to say, that at some point when its velocity is 20 kilometer per hour, the train actually says that there is a repair work, and it instantly keeps its speed constant with 20 km per hour. So after 1 kilometer, again it accelerates and again it decelerates like this. So in that case, this will be the area that I have to find. But this area, the train is not moving with a constant velocity. Usually it does not move with a constant velocity. So this will need some time to solve. You can solve this question in this way, and your answer should be something. It will not be a simple number. It will be a root 3, something like this. You try this question solving like this and send me the answer in my WhatsApp number. I will check. That I have done this question like this also, and the answer was something that I said that root 3 or something like that, but it did not match with the actual given answer, which was 1/62. Then I tried the second method, which actually matches with the given answer. The question should have that note that this 1 kilometer of repairing work actually lies in between the region where the train normally runs in 60 kilometer per hour. Then only the answer is 1/62. Otherwise, it will be a different answer. You try to solve it. Let's see the last question. It says a particle is moving in a straight line with constant acceleration, covers 3 equal distance without changing the direction. In the first and last path, the average speed is 6 and 12 meter per second. Find the average speed in the middle part. Okay, let us first try to solve this question with its. Let us try to solve this question with its VT graph. Okay, there are also several methods to solve this question. By writing equation also you will be able to solve it, but I will try to solve it in VT graph. Let us first draw its VT graph. So if I say it is V axis, it is time axis. It does not mention about the initial velocity, so it may be anything, right? Let us assume that it is V, it is T, right? So this the we are observing its motion from this time here only. So this is the first half, first 1/3 of the distance, the second 1/3 of the distance, and it is the third 1/3 of the distance. So let us assume this time interval I am talking about is T1, this time interval is T2, and this time interval is T3. Right? It is mentioned that all these 3 distances are same. How do I find distance? It is nothing but the area under graph. Right? So if its average velocity is 6, then I can simply say that this area under graph is 61. If its average velocity is x, I can say it is xt2, and if it is 12, it is 12t3. So the first equation that I can have is 61 equal to xt2 equal to 12t3. I hope you have understood. I have used the equation for average velocity. Average velocity is equal to displacement divided by time, right? So the as it is moving in the same direction, the velocity and this speed are the same. So what is displacement is equal to average velocity multiplied by time, right? That only I have done here. So from there I can write this one equation. Now what is average velocity? Suppose this velocity is u and this velocity is v. So I can say the average velocity will lie in the middle, right? It will be u plus v by 2 here, right? Average velocity, if you find it will be u plus v by 2. Let us try to prove it. If it is u, if it is v, then you can see that what is the area under this graph. Area under this graph is half into trapezium area u plus v multiplied by t1. This is area under the graph, this is delta s, and if I divide it by delta s by t1, then I will find the average value. Average value is equal to u plus v by 2 only, right? So this is the midpoint of this u plus v by 2. Similarly, it is the midpoint of this line. Say it is x, right? It is u plus v by 2, which is given as 6, and this is u plus v by 2, which is given as 12, right? So now if I draw a triangle like this, if I draw a triangle like this, you can see it is a right angle triangle where the slope is same of this line. This red colored line, you can say hypotenuse, the slope is same as the acceleration is constant, right? So I can say that if this is 6, this is 12, so this left out part is 6, this height of the triangle is 6, this part will be x minus 6, definitely this part will be x minus 6. So we have two different similar triangle. You can see this is smaller triangle and this bigger triangle. So can I say that this smaller triangle base divided height divided by base. Now what is the base for this? This is t2 by 2, this is t1 by 2. So can I say x minus 6 divided by t1 by 2 plus t2 by 2 is equal to, for this bigger triangle, the height is 6 divided by what is the base? This is t1 by 2, this is t1 by 2, this is t2, and this is t3 by 2. So this is t1 by 2 plus t3 by 2 plus 2 t2 by 2. Actually it is t2. So I have now two equations and I can solve for x from these two equations only. What I will do, I will cancel this 2, 2, 2, 2, right? And then I will represent all this t1, t2, t3, all these three terms in terms of t2 only, right? In terms of t2 only. So I can say from the first equation, I can say t1 is equal to x t2 by 6 and t3 is equal to x t2 by 12, x t2 by 12, right? Now you can see that this terms will get cancelled out, right? And I will be only left with x. So x minus 6 divided by t1 plus t2. t1 plus t2 is t2 into 1 plus x by 6, and it is 6 divided by t2. If I take common, 2 plus t1 plus t3. t1 is x by 6 and t3 is x by 12. Right, now t2 t2 gets cancelled out. Now I think that we will be able to solve this equation because it is only equation of x. I think there will be a quadratic of x and I will solve for x, right? So to solve that part, I will erase this diagram. I hope that you understand this VT graph. Now let us try to solve this equation. So you can see it is x minus 6 multiplied with 2 plus 3x by 12, 3x by 12 is equal to 6 into 1 plus x by 6. So if you solve it, it is x by 4. So it is x minus 6 into 2 plus x by 4, that is 8 plus x divided by 4 is equal to 6. plus x, right? So I will multiply this, and I will multiply 4 with this side. So this is 8x minus 48, 8x minus 48 plus x square minus 6x is equal to 24 plus 4x. So I will have x square for this, 8x minus 6x is plus 2x, and minus 4x is minus 2x, and it will be minus 48 minus 24, that is 72, I think, that is equal to 0. Can I solve for x? This is a quadratic equation. The answer will not a good one, I think, but I can find the answer definitely if I solve it. So x will be minus b plus minus under root of b square minus 4ac, so that is 4 into 72 divided by 2, right? So I cannot take the minus and I will only take the plus sign, 1 plus under root of, I will take this 2 inside, so it will be 4, 4 gets cancelled out, so it is 1 plus 72. So the answer is 1 plus root 73. That is the answer of this question, right? I think you have understood this one. So today we will start with rectilinear motion under gravity. Here we will assume that gravitational acceleration is a constant. Although we will study in the chapter gravitation that gravitational acceleration varies as we move away from the Earth's surface. But here we will be very close to the Earth's surface. Suppose this is the Earth's surface. Suppose it is the Earth's surface, right? And as you see that our observation range is very near to Earth's surface, right? When you throw a particle in air, the particle will never go beyond a particular limit, right? And the limit is very small compared to the Earth's radius. You can say that it may be maximum 10 meter, 20 meter, right, in this range. And the radius of Earth is near about 6,000 kilometers, right? So that is very negligible with compared to the Earth's radius. That is why we will always assume that in these examples of rectilinear motion under gravity, the gravitational acceleration, right? What is gravitational acceleration? I hope you know that when you release a particle, that will always come towards Earth, right? Towards the Earth's surface, because Earth attracts all the bodies towards itself. So this acceleration is always downward, we will say that this acceleration is downward, and its value we will assume to be a constant. We'll assume this value to be a constant in this small range. Although in the chapter gravitation you will see that when you move in a certain distance, where the distance is compared to the Earth's radius, right? Suppose you launch a rocket, the rocket will not move up to 10 meter or 20 meter only. It will go away at a very large distance from Earth's surface. In that case you cannot take gravitational acceleration to be a constant. But here for our calculation purpose we assume that gravitational acceleration is a constant, and the value of this constant you can take 9.8 meter per second square if in your question it is mentioned, or if it is not mentioned you can take 10 meter per second square for your calculation purpose, right? In most of the cases if you take 10 meter per second square your calculation becomes easier. So we will always take gravitational acceleration to be like this, right? So this is called gravitation motion under gravity, which is nothing but you can see that this is a constant acceleration. So this is rectilinear motion under constant acceleration, the same thing, and we are going to use the similar equations that we have used in the last class uh, in motion under constant acceleration, right? S equal to ut plus half at square, v equal to u plus at. and v square equal to u square plus twice as. The similar type of same equations we are going to use here. But remember that here acceleration direction is always downward and it is a constant. Okay. So let's see what do we have in this slide. This is a schematic diagram I have shown to represent the motion under gravity. What is going on here? You can see there is a ball. You can imagine there is a ball, right? There is a ball, and you throw this ball upward. This ball was initially in your hand. You throw this ball upward in air with a certain initial velocity u, right? U, I have given it a vector. So with certain initial velocity u, you have thrown this particle upward, and you should note that after going certain height, which I have said maximum height h max, after going to certain height, the particle again comes back, right? Again it returns to the original position. So this is what generally happen, and the total time the particle has taken to move from this point to this point, to move from this point to this point, is called time of flight, that I have denoted as capital T. Although in my drawing you can see there is a horizontal displacement of the particle, but actually it is not. I have shown it this horizontal displacement to clearly show this picture. Otherwise you can say that these two points actually are the same point, right? They will converge. These 2 points are actually the same point. So the particle will move along a straight line and come along the same straight line. That is why I say it is a rectilinear motion, right? Now in rectilinear motion, this type of motion, you can always assume your vectors, and you can define upward vector to be positive as I have defined. You can take the reverse direction positive also, and downward direction negative I have defined. It is my definition, right? You can choose to be upward negative, downward positive. Also, if in your question it is not mentioned, then they should not hamper your answer, right? Whatever direction you take positive, but you need to remember that the opposite direction has to be negative. So in that way I can say that u is positive, u is the initial velocity, and acceleration is negative, which is minus g. Can I write these initial conditions? And you can see that these conditions have to be fixed. These conditions have to be fixed. You cannot change this condition until unless there is some other external force acting on the ball, right? As long as only gravitational force is acting on the ball, you cannot change your assumptions. These are by default assumptions, you cannot change those. So what is the displacement equation I can write? Delta S equal to ut minus half gt square. That will be your displacement equation. And what will be the velocity equation? V equal to u minus gt. And what will be v square equation? V square equal to u square minus twice g into delta S. Right? I hope that you all have understood this example, these equations, how we have written that. Is there any doubt in these equations? Anyone? Okay. So there is a very common misconception, and there is a very common mistake by students, that they take this g negative in the upward motion and they take g positive in the downward motion, right? So you do not do that mistake. G is a constant, so you cannot change the direction of a constant vector, right? You should understand my words, that if some vector is constant, it is constant not only in its magnitude, but it is also constant in its directions also. So once you have taken acceleration to be minus g and it is constant, so you have to keep this minus g constant throughout your calculation, right? What type of calculations we can do from this type of questions? We can solve this type of question. First, let us assume what is h max. Can I calculate h max? How do I find h max in this equation? Can anyone tell me how do I find h max?
So v equals to 0.
At h max, yes. Yes, good. At H max V equal to 0, so you use third equation, and as initial position vector is 0, so displacement and position vectors are the same here, right? That also you have to remember. So just try to calculate H max. Have you calculated H max? What you have got? V square. Yes, u square minus 2g h max. So what is h max? You can see it is u square by 2g. Good. And can you tell me what is the time of upward journey? What is the upward journey time? How do I find the upward journey time?
U by G.
Yes, v equal to u plus at. So v equal to u minus gt up. So upward time taken is equal to u by g. And how do I find the total time? Total time of flight?
2UG.
2u by g. 2u by
U by G.
That I can find by which equation?
So second means V equals to U minus GT only.
V equal to u minus gt. How you can apply v equal to u minus gt to find total time?
Minus U.
That yes, that if you know that when it will come down, its velocity will be minus u, then you can use this one. Otherwise, you can use this s equal to ut plus half at square. Can you tell me what is the displacement when it is here?
0.
0. So 0 equal to ut minus half gt square. So in that case, you can find the solution of this equation is either t equal to 0 or t equal to twice u by g. Right? Why t equal to 0? You can see that at t equal to 0, the particle was at this initial position, so displacement was 0. And again at t equal to u by g, it is at the same position, so the displacement is again 0. Right? And you can see one important thing, that it's uptime. Uptime means the time taken to for its upward journey, and that is equal to its time taken to for its downward journey. Right? Because t down, if you find, then you will find it is the same thing as u by g. Right? So that is why I have said that this particle, the motion of this particle is actually symmetrical about this line. The motion of the particle is actually symmetrical about this line. That means its upward journey is symmetrical about it as its downward journey. So the time taken to upward motion is equal to time taken for its downward motion. And you can also see that its downward velocity when it touches the ground has the same magnitude as that of its upward velocity of projection. Right? How can I prove that its downward velocity is minus u? How can I prove that its downward velocity is minus u when it reaches the ground?
Sir, time to go up equals to time to come down, and
Yes.
then if you consider that V equals first you consider the time, you find out the time when V equals to 0, and then when we reach the highest point, there we will consider U equals to 0.
You are applying,
And
yes, you are
The
applying.
third equation we can apply an s equal to u square by 2g h max.
H max. Why you will apply H max? Because I am here now.
Sir,
No, sir, considering from v equal to 0 from the topmost point.
Okay. Then you will find again. Acha. Then I will find again. I can use only one equation to solve that. You use this one.
Yes, sir.
The
V
second
equal to-
equation. V
Yes, sir.
equal to u minus g. I can put the time capital T instead of small t.
Mhm.
Yes or no? So it is u minus g into what is capital T? It is 2u by g. Can you see that the velocity is coming minus u? Right. So in this way, we
Another way also.
in which way?
Sir, we can use the third equation. V square equal to u square minus 2g delta s.
Yes.
Sir, so then we
Delta
will
S.
put delta s equal to 0.
0. Yes, you can say that v equal to plus minus
Equal
u.
to plus minus u.
Yes.
And
So
when
initially it is
we
plus
can
u. Yes.
Minus.
Finally it will be minus u. That is also correct. Right? So yes, basically it is happening because of there are no air resistance or external force acting on the ball. right? As we have seen that it is only gravitational force acting on the ball, you can also conserve its total energy. Energy conservation principle we will study in this phase only after Newton's laws of motion. Then also you can see that as there are no other external force, so its total kinetic energy remains constant. So if it is half m u square here initially, finally when it will come here, it should have the same kinetic energy, right? So that is why also its speed remains the same. But in the same question, if there is some air resistance that resists the motion of the ball, then the two motions will not be symmetrical. Then upward journey and downward journey will not be symmetrical, and it may happen that when the particle reaches the initial position, it will have some different speed, right? But that is a different issue. For that you need more information which is not given right now in our question. So for our analysis we will neglect air resistance and we will only assume the gravitational pull on the ball. Okay, so I hope you have understood this part. Now there is another important thing to understand, that when you project a ball upward, when you project a ball upward, you can see that the ball reaches a particular height twice. It crosses this height twice, once in its upward journey, once in its downward journey. Yes or no? Can you see that any particle that you throw, it crosses a particular height twice. So suppose from initial position it takes t1 time to cross the height first time, and in its downward motion it takes t2 time to cross the same height, right? So can you tell me what is the total time of flight of the particle?
T1
Yes, total time of the total time of flight of the particle, from that information can be found as t1 plus t2. How we can say that?
Sir, the time means the time needed to rise that intermediate height is equal to the time needed to come down from that intermediate height
Yes.
to the ground.
Yes.
So from that
Good.
instant, if we add the time interval t1 from
Then
the
it is
t2,
yes, yes.
we
Good.
add
Good observation. So what he tries to say that from here to this intermediate height to this height, the particle takes t2 time, as it is given in your question. To come from here to here, it takes t2 time, and again to fall from this height to the ground level, it will take t1 time, as it takes t1 time to reach this height from ground level. And this motion is symmetrical, so if it is t1 time, then it will also be t1 time. So total time of flight will be t1 plus t2. That you should remember, because sometimes it is useful. Understood? I hope that we have understood all this concept of rectilinear motion under gravity. So we are now good to solve few numerical questions regarding this. You will be able to solve these questions easily, because it is only an example of rectilinear motion with constant acceleration. Okay, so let us try the first question, this one. You think it like this: there is a cliff or a tower. Someone projects a ball upward with a velocity using. So what the ball will do? The ball will move to a certain height. Suppose this one. The ball will move to a certain height. This is the maximum height of the upward motion. Then the ball will again come back, right? And it will fall below the tower. So according to your question, when the ball reaches a particular height h above the point of projection, which is this one, its speed is, suppose, v. What height? Height h. And when it reaches h below the tower, below the point of projection, then its speed is 2v, right? So it is talking about speed because it may be upward, downward. In this lower case it is strictly downward, but when it is above h, it may be upward or downward. So I need to find what is the maximum height attained by the particle, capital H, that I need to find. Look here, first, after seeing the question, you should think that there are three equations that we can use with constant acceleration motion, but there is no information of time given in this question. So if in your question you cannot find any information of time, you can always use the third equation of motion, right? So in your third equation of motion, it says that v square equal to u square minus 2gs I will use, because acceleration here is minus g and I have taken upward vectors to be positive. So v square equal to u square minus twice g into h. This is the first equation that I have written when the particle reaches a small h above the point of projection. Right? Similarly, when the particle reaches below the same height of the point of projection, I will write this equation 2v whole square equal to u square minus 2gh. Have I written something wrong in this equation? Can you find what is wrong in this equation?
Plus.
Plus only.
Plus 2gh. Why I will write plus 2gh?
H is negative.
Yes,
Negative.
good. Because h is a negative here, as you are talking about displacement, right? So as I am going down from the point of projection, this displacement is definitely minus h. So 4v square equal to u square plus 2gh. That is your second equation. And if you have the first equation and you multiply it with 4, then you will get 4v square is equal to 4u square minus 8gh. Now I will equate these two equations to eliminate v, and you will find u square plus 2gh is 4u square minus 8gh. So what is your 3u square? That is equal to 10gh, and u square is equal to 10 by 3gh. But what I need to find? I need to find h max. Do you remember the formula for h max that we have just used?
U square by 2g.
U square by 2g. So if I divide u square by 2g, it will be 5h by 3. That should be the answer of your question. I hope you have understood the solution of this one. Anyone have any doubt? Bolo, do you have any doubt? Alright. I assume no doubt, so I will move to the next question. So, what we have in this question, let us try to understand. There is an aeroplane which drops a parachutist. Drops, whenever you find this term drops, that means its initial velocity is 0. Right? When you drop something, its initial velocity becomes 0. So after covering this 40 meter, so this 40 meter, this parachutist move freely under gravity. After covering this 40 meter, he opens the parachute and retards at 2 meter per second square, and then finally reaches the ground. Right? So here he starts his journey with velocity u equal to 0. Right? He moves this 40 meter distance with a constant acceleration downward g. And suppose the velocity here is v. And after that, what is the acceleration? After that, its acceleration is upward 2 meter per second square. Can I say that its acceleration is upward? Because it says that it retards. It says that it retards. So retardation means opposite to the acceleration or opposite to the velocity. Right? You always remember this difference of acceleration and retardation. Acceleration and retardation. retardation. That if velocity and acceleration both are in the same direction, then I can say it is acceleration, and if velocity and acceleration are into opposite direction, I can say it is retardation. That is the only basic difference between acceleration and retardation. So as the person comes down, so retardation means its acceleration is upward, and acceleration means it is downward, right? And he finally reaches with a speed 2 meter per second. So its final velocity is 2 meter per second. Let us first calculate the time t1 to reach that 40 meter, to cover this first 40 meter distance. How do I find this t1? Which equation I will use? Can you tell me?
Second equation.
Equal to ut plus half
S
80
equal
square.
to ut plus half 80 square. What is my S here in this case?
40 meter.
Plus 40 or minus 40?
Minus 40.
If I take downward directions negative, then it is minus 40 obviously. Is equal to minus of half into g is 10 into t square. So from there, can I find the value of t1?
Yes, sir.
What will be the value?
2.
2 root 2 second.
2 root 2 second. Good. So what is the velocity here? Can you tell me what is the velocity after reaching v equal to
20.
yes, v equal to minus 10 into 2 root 2. So that is 20 root 2 is the velocity, and the final velocity is minus 2. Can you say final velocity minus 2 because it is downward? So can I use the first equation v equal to u plus 80 to find out the time? So it is
Yes,
minus 2 is equal to minus 20 root 2 minus 10 t2. From there you can make all of them plus. So t2 will be your
10 root minus 1.
10 root 2 minus 1. So what is the total time?
Acceleration will be 2 meter per second square.
Acceleration is 2. Yes, sorry. Acceleration is 2. Yes, acceleration is 2. I have only divided it with 2. Then this will be the t2 value, and this is the t1. So what is the total time of flight? It is t1 plus t2.
12 root 2 minus 1 second.
12
Sir?
root 2 minus 1. Yes. Tell me.
So the question required the time, including the time before opening the parachute.
Before opening the parachute, you need to find the time. Otherwise, how can you solve it?
How long he remained in the air?
Oh, I thought that
Is how long it remained in air. Even if he does not open in the parachute, he is still in air. Okay?
Yes.
Alright. Solve this one. This is a question regarding graph. So you need to plot a graph. Right? 3 graphs you need to plot. Just go through the question, try to plot the graphs. So first 2 we will solve it like this. We'll first draw AT graph, then VT graph. AT graph it is not given, but again you can plot it, no problem. AT graph is simple. Then lastly we will plot ST graph. Right? Okay. So this is AT. This will be your VT. This will be ST. S means position, or here in this question you can also take S to be delta S or displacement. Why? Because you can see that the initial position is only the origin, right? So your initial position vector for this question is 0. Initial position vector is 0. So as initial position vector is 0, your distance and displacement and position time graph will look alike. Displacement and position time graph will look alike. Okay. How do I plot its acceleration time graph? Can you see that it will be your acceleration time graph? Yes or no? Acceleration time graph.
Yes, sir.
What is VT graph? Can you explain how the VT graph will look like?
So,
VT graph will be a straight line or not?
straight line.
Straight line. What will be the slope of the VT graph? Positive or negative?
Increases to 0 and again. So it will be a straight line with
Negative slope.
Negative slope.
Yes.
Negative slope.
Straight line with negative
Yes.
slope. And it will be like this. Have you drawn VT graph like this?
Yes, sir.
Yes, sir.
Yes. I have seen few students to draw their VT graph like this. Why? They assume that in their downward journey the acceleration becomes positive, but it will never happen, right? How in your downward journey you can suddenly change your acceleration? So it will never happen, right? So your VT graph will be only a straight line with constant slope because acceleration becomes slow. Acceleration is constant. Now if you see that if I draw a straight line like this, how your ST graph will look like? Can I write the equation for S? What will be the equation for S? S equal to plus ut minus half gt square. Is this the equation that I will follow to plot this graph? Now in this
Yes.
one you can see that the coefficient with t square that we can consider to be our a is negative. So your graph will be a open downward parabola with y intercept 0, right? And can you tell me which one is your symmetric line for that? What is your symmetric line for this parabola?
Yellow line.
Yes, that yellow line that I have plotted vertically, that will be your symmetric line.
The symmetric line.
Why this is the maxima for this graph? Can you tell me why it is the maxima for this graph?
It's a highest point velocity becomes 0.
Yes, because at highest point velocity becomes 0, or there is another explanation that the slope at this point is 0. Slope of the tangent is 0. What is slope of the tangent? It is nothing but ds by dt. ds by dt means velocity, right? So whenever velocity is 0, it must have a maxima or minima for the ST graph. So I hope that you have plotted these three functions clearly. There is no doubt. There should not be any doubt. We have plotted this type of question several times earlier also. Now it is time to plot velocity versus position or displacement. It may be position or it may be displacement. Both are same for this question, right? So how do I plot a velocity displacement graph? Do I find a equation with velocity and displacement? It is v square equal to u square plus, it will be minus twice g into delta s. Can I write this equation? Yes or no?
Yes.
Yes. So can I find this equation like this? If I slightly modify this equation, what is delta s? You will find it is minus of v square by 2g and plus u square by 2g, right? And if I try to write this equation as y equal to ax square plus bx plus c, can I write this equation in this form? Can you relate these two equations? Yes or no?
Yes.
Where your a for this equation, a is equal to minus of 1 by 2g.
Yes.
What is the value of b? Can you tell me?
0.
0. And the
0.
value of c is u square divided by
2.
By 2g.
Right. So these are the values. Now I can easily plot this function. Try to plot this function. It is a parabolic curve that we have already seen how to plot. It is a parabolic function, right? If I take my y-axis to be here in this way and x-axis to be here, then how do I plot this? Y versus x. You can say it is a open downward parabola. What will be the symmetric line? Can you tell me what will be your symmetric line for this graph? Y-axis itself, because symmetric line will be x is 0, right? Minus b by 2a, you will find that x equal to 0 for that case. So this is only your symmetric line. So your graph should look like this. If you have understood, if you have not got this, then tell me. Does that graph look like this? Yes. Have you got this graph like this, or you have got different? You have got a different value. Okay, this is delta s. Y I have put as delta s, and x I have taken as v. Can you tell me what is this value?
V equals to 0.
Identify
U
this one.
square by 2g.
No.
No.
In this
Sorry.
one,
No.
it is v.
Small a.
What is this one?
Delta is equal to
Can you tell me what is this one?
delta is equal to 0. So
Only U square.
Huh?
U.
small a
It is plus
u
u. It is plus
It's
u.
very
plus u.
Plus u. Look, delta is 0. Huh? At this point, delta s is 0. Delta is 0 means you are at a starting point. Starting point velocity is plus u.
Yeah.
Can you tell me what is the velocity at this point?
Minus u.
Minus u. Yes. Can you tell me what is this point?
G. U square by 2
h.
g.
Yes. Small h. From this diagram, you
H,
can say it is plus small h. Okay, and what is this one?
The 2A.
Huh?
Capital H.
Minus
Sorry.
capital H.
Minus capital H.
Capital.
Minus capital H. Now you should note that there is no need to draw this line below this. Do you accept this one? Should I plot this line? Should I plot this one or not? This part should I plot, or this part will not be there?
No, sir.
No.
This part will not be there because delta s starts from 0, right? Delta s does not start from something negative. So that is why I can erase this part, right? So that is your graph of delta s versus v. Although if you have to plot v versus delta s, then you can just rotate this graph, right? If you just rotate this graph for v versus delta s, you will find the same graph. Just I will rotate it like this. If it is v versus delta s, I will take this one to be v. I will take this one to be my delta s, right? And then how your graph will look like? Your graph should look like this. Yes or no? This is minus capital H. This is minus capital H. It is plus small h. It is plus u. It is minus u. Have you understood this solution?
Sir, in the first graph,
Yes.
so that third quadrant part will be also erased.
Third quadrant, this part.
Yes, sir.
This part you are talking about?
Yes, sir.
No, this ball is coming down. Na? After crossing this point, the ball is coming down. So its displacement must be negative. If you only keep your graph in first and second quadrant, your displacement is only positive or 0. You can only show displacement negative in third quadrant or fourth quadrant. Right? Okay, I hope it is clear to all of us.
Yes, sir.
All right. ठीक है. Okay. So till now what we have studied was rectilinear motion with constant acceleration, but now we will study rectilinear motion with variable acceleration. What do I mean by variable acceleration? Now acceleration time graph will not be a straight line parallel to time axis. Right? Now what type of graph it is? It may be anything. Acceleration now will be a function of time, and what is that function? You can take any function of acceleration. Right? So try to understand how to solve this type of questions. We will use a very general equation of motion. Till now what we have used was a particular equation of motion. The particularity of that equation was that acceleration remained a constant. During this entire motion, the acceleration remained a constant. But now we will talk about a general equation of motion where acceleration will be variable, velocity will be variable, position or displacement will be variable. So all of them will be variable, right? So how to solve this type of question? For that, we have to understand general equation of motions. What are general equation of motion? Now these are general equations of motion that already we have discussed. First three equations we have discussed, at least first two equations we have already discussed in our class. If you remember, we have discussed the instantaneous velocity, we have discussed the instantaneous acceleration. Yes or no? Do you remember that?
Yes, sir.
Okay.
Yes, sir.
Okay. So,
Yes, sir.
taking the first equation, say v equal to dr by dt, we can say v equal to dr by dt or ds by dt, or you can say, and acceleration is equal to dv by dt. We can also modify this equation like this. We can say acceleration equal to dv by ds into ds by dt. You can do this type of modification with this differential forms, so that ds will get cancelled out and dv by dt will remain. So what is this ds by dt? Can you tell me what is this ds by dt again?
V.
V. So can I say that acceleration is nothing but v into dv by ds? That is the third equation that I have written here, right? Acceleration equal to v into dv by ds. So if in your question position time function is given, s is a function of time given, then what you can find from there, by differentiation of s with respect to time, ds by dt, you can find v, and by differentiating v with respect to time, you can find a. Is vice versa possible? That means if in your question acceleration as a function of time is given, can I find velocity as a function of time, and from there can I find position as a
Yes,
function
sir.
of time?
Yes, sir.
So how do I solve that? We will do the integration, right? For all those who do not have any idea about integration, let me give you some basic idea of integration and how do I perform integration. It is very simple. You only need to remember one equation for at least few physics classes, right? For next few physics classes, only you remember these two equations, right? I will write here that if x equal to c into x power n, then the differentiation of that is some constant into n into x power n minus 1. And if x into n dx, if I integrate this term, then I will get c into, can you tell me what is the integration of this form?
C into x to the power n plus 1
N
by n
plus
plus
1, right? Here you should remember that n is not equal to minus 1. N cannot be equal to minus 1. Otherwise, you can use this equation. Okay? So, n is not equal to minus 1. Otherwise, you can use this equation. Suppose I am going to write this first equation, that v is equal to ds by dt. So what is ds from that first equation? If I modify that, it will be v into dt, right? So I will take a integration in both the sides, ds integration and v dt integration. Now after you do that integration, you should put a limit of integration,
limits.
right? Suppose your limit should be t naught to t and s equal to s naught to s, right? Then you can find the value of s. For example, let us assume that a velocity of a particle changes as to say 3t square minus 2 in this form. Velocity of a particle changes as 3t square minus 2. Now, if I try to find what is the displacement of the particle, what is the displacement of the particle at say t equal to 2 seconds? How do I solve this? What is the displacement of the particle at t equal to 2 seconds? How do I solve this? So my answer will be that write
12.
v as ds by dt, and you will get that it is ds by dt is equal to 3t square minus 2. What will be ds now? It is 3t square dt minus 2 dt. Do you follow the process steps? So if I integrate this, then I will find this. I can take constant terms out of the integration, right? Can you see this one? This integration? Now what will be the limit? Limit will be at t equal to 0 from t equal to 0 to t equal to 2 second. Limit will be from t equal to 0 to t equal to 2 second. And from here, the initial displacement was 0 and final displacement is delta s. So now what I will do, I will subtract the lower limit from the upper limit. What is integration of ds? Integration of ds is nothing but s. The lower limit is 0, upper limit is delta s. Similarly, can you tell me what is integration of t square dt? What is integration of t square dt?
T cube by 3.
T cube by 3, right? So 3 gets cancelled out, and you need to put the limits from 0 to 2 and minus 2. What is integration of dt? T. Integration of dt is t, 0 to 2. Now how do I solve this equation? Just have a look. So the first expression delta s, I will put delta s minus 0 as it is, the function is there, equal to t cube. So I will put 2 cube minus 0 cube. Can you see what I am doing? I am just subtracting the lower limit from the upper limit, maintaining the same function, and minus 2 t is there, so it will be 2 minus 0. So what is delta s? Is equal to 8 minus 4, that is 4. That should be your answer.
4.
If you have not understood how I have solved this one, then you should ask me again, because this part is new to most of you, or if you have done this in your basic maths class, then it is very good. It is okay that you have understood this part, but you have not understood, there is no problem, because it is new to you. You need to only follow the procedure that I have followed. You need to follow the procedures or steps only, then you will find your answer. Have you got this one? Is there any doubt? You can ask me. Okay, in the same question, can you tell me what is the acceleration of the particle at t equal to 2 seconds? What will be acceleration of the particle at t equal to 2 seconds?
12.
How do I find acceleration?
dv dt.
dv by dt. So dv dt, if I do it, then it will be 6t, right? So 6t means it will be 12 meter per second square. That should be your answer, right? And this will be 4 meter. That will be your answer. So in this way, you can find velocity if acceleration is given, and displacement if velocity is given, and we can find all the values if something is given in your question, right? I hope most of you could solve this question. Constant, no, look, constant will only come when you do not put a limit, right? Constant of integration will only come when you do not put a limit, but here always we have put some limit in the integration, from 0 to 2, from 0 to 2, from 0 to delta s. This types of integration is known as definite integration, and when you integrate without a constant, it is called indefinite integration. Yes, tell me.
So we are doing here definite integration.
Yes.
Yes, but before evaluating the limits, the task basically we are doing is indefinite integration, and then we are putting the limits, evaluating the limits.
Yes.
So we should constant will get cancelled, but it's better to write the constant.
No,
Means
no. Here you do
it's
not have to write the
correct.
constant. Look, if you have a function, the function may be y equal to mx plus some constant, right? It is a function y equal to mx plus a constant. But if I do not give you the value of that constant, instead I say that at y equal to 1, x equal to 2, and at y equal to 3, x equal to 4, you can always find the constant from this two given equation, right? So if you do not have this constant, then you have to give me two strict equation, that is why two strict value of this function. Just I have said you that if you know y equal to mx plus c, if you know the constant, you will give me the exact value y equal to mx plus c, no problem. But if you do not give me the constant, then you have to give me the two value of x for two values of y, right? So that I can calculate the constant term from this given equation. So that is why it is always needed to put the constant if you are doing an indefinite integration, means if you are not putting the limits. Otherwise you have to put the limits, and you do not if you are even if you do not put the constant in this definite integration, you are correct. Yes. No, with respect to physics, with respect to maths, nothing like that. In physics also, in maths also. In physics, several times we will use indefinite integration. There definitely we are going to write the constant, right? But whenever you are using limits in your integration, you do not have to put the constant. Okay. So I think it is okay to all of us, this thing, general equation of motion. There are several questions that we can solve with this general equation of motion. Let me first solve this one. Yes, let me first solve this question.
3.
No. Do it, you will find your answer. Okay. So let us first try to find the acceleration time function from that straight line. If you know that a straight line has a form y equal to mx plus c, here the straight line should be a equal to some slope m into t plus some constant like this. What is that constant? You can see that the constant is y-intercept. So it is y-intercept 1. It is shown in the diagram. So c is equal to plus 1. And what is the value of m? You can see the value of m is tan of this angle. Now tan of this angle is equal to minus tan of this angle, which is 45 degree. So the slope of this straight line is minus 1. So the equation for acceleration will be 1 minus t. I hope you have got this equation of straight line by your own. If you have not understood, then ask me. So the equation of the straight line is 1 minus t. Now, as I know the function of acceleration with respect to time, I can easily find the velocity by integrating this function. I will write dv by dt is equal to 1 minus t. So dv equal to dt minus t dt. And it is given that it starts from rest. That means its initial velocity is 0. Right? So when I put the limit at t equal to 0, I will put its initial velocity to be 0.
Sir,
Yes.
so 4.
Yes, the answer will be 4. And when I put the upper limit, look here what I have put. I have not put any value for the upper limit. I have kept it a general thing. Why I have kept a general value instead of putting any numerical value, say 1, 2, 3? Why I have kept it general? Can you tell me? If
So
I
we would integrate it again to find the displacement.
Yes, because my
Find a
purpose,
displacement equation.
yes, my purpose is to form the equation. My purpose is not to find a particular value. If my question were that find the velocity at t equal to 1 second, I would have put my limit from 0 to 1 and 0 to v. But my task is to find the function of velocity. So if I integrate this, it will be v minus 0, it will be t minus 0, and it will be t square by 2 from 0 to t. So again the function is becoming v is equal to t minus t square by 2. Every one of you should have got this value. V equal to t minus t square by 2. Have you found this value? This function is correct? Yes or no?
Yes, sir.
Alright. Now let us put the values. Now let us put the functions. AT and VT graph. First I will put AT and VT graph. So if you plot AT graph that is given in your question, this is your AT graph, right? This is your AT graph. Just below this AT graph, let me plot the VT graph. Can you identify what type of function it is? How the graph will look like for VT?
Downward parabola.
It will be a
Downward parabola.
Yes, it will be a downward parabola because A is negative, so it will be a downward parabola. What is the y-intercept of this graph? 0, right? So it will start from 0. And can you identify what is the symmetric line for this graph?
X is equal to and at t is equal to 1.
Where acceleration is 0. Yes, at t equal to 1. Why? Because when acceleration is 0, velocity should have maximum or minimum thing. Yes or no? Because if you remember, what is the slope of the tangent on velocity time graph? Can you tell me what is the slope of the tangent on velocity time graph?
Acceleration.
Acceleration. So if acceleration is 0, that means the slope should be 0. So the graph of velocity time should have this one. Could you understand how I have plotted this graph? Alright. So with respect to time, I can say yes. Acceleration. Acceleration is 0 at this instant. So velocity should have a maxima or minima. As it is downward parabola, it should have a maxima. Alright. So this point is 1, this point is 1, 0, this point is 1, this point is 2 seconds. I could not hear you. If you have some doubt. I cannot hear you. You can write your question in the chat box. Yes, write your question in chat box. Okay. Now look, there is yes. Okay, good. Now tell me one question that is not here. I will give you that question. Can you tell me the time interval between 0 to 4 seconds? Can you tell me the time interval when the particle retards? When the particle retards. Tell me the time interval when the particle retards.
Sir, from 1 to infinite.
From 1 onwards.
1 second to 2 seconds.
1 to 2 seconds.
Sir, velocity vector and acceleration
yes.
different direction.
Good observation. Look, For 0 to 1 second, what is velocity? Positive. What is acceleration? Positive. Can you check that from the graph? From 0 to 1 second is acceleration positive and velocity positive. If both are positive, that means the direction of both are the same, because here in 1D motion I represent the direction by their signs. So if both are positive, that means it is acceleration. For 1 to 2 second, what is the value of acceleration? Positive or negative? For 1 to 2 second, acceleration is positive or negative?
Negative.
Negative. And what is velocity? Positive or negative?
Positive.
Positive. So here comes the retardation. Right? Here is the retardation. Again, from 2 to 4 second, what is acceleration?
Negative.
Negative. And what is velocity?
Negative.
Negative. So it is also an acceleration. This is accelerated motion. Right? It is accelerated motion. And this is retarded motion. So you can also identify it from graph. Alright. So our next question is that I need to find the distance traveled by the particle. Right? So if I find the area under graph of Vt, what do I get? Distance or displacement? Area under graph Vt? Displacement. So how do I find displacement? Can I say it is integral of v dt? Do you remember the general equation? ds equal to integral of v dt?
Yes, sir.
So I will put the value of v here, which is t minus t square by 2. And from where to where I will put my limits?
0 to 4.
0 to 4. Can you find the value for that integration 0 to 4?
So, but that will come negative.
Sir,
Yes, that will come negative. No problem. Displacement can be negative.
So,
Displacement can be
find
negative.
distance.
sir,
Yes, tell me.
sir, here it is required to find distance. So we will not find displacement first. We will find the instant when the velocity turns negative, and then from there we will calculate the distance.
Yes. Actually, we are going to do that.
Until that
But
time we will calculate.
we can also do it in a simpler way if I find the displacement. Can you find the displacement? What is displacement? Have you got this one? What is displacement?
Yes, sir.
Just try to find this integration by your own.
Minus 8 by 3.
Yes, this is t square by 2. That means 16 by 2, 8. And it is t cube by 6. That means 64 by 6, 32 by 3. 32 by 3.
32.
So it is 24. So minus 8 by 3. Have you got this one?
Yes,
Now,
sir.
why it is negative? Can anyone tell me why it is negative? Because you can
It's
see,
the displacement.
yes, displacement.
The velocity has turned.
Yes, when you are calculating the area under graph, if this upper area is A and this lower area is B, and if the lower area is B, what you have calculated here actually is A minus B. Can you understand this one?
Yes, sir.
Because this area is below this time axis, I have taken it negative while integration. That is why I have found it negative. It is A minus B. But if I have to find the distance traveled, what I have to find actually? What is the distance?
A plus B.
Distance should be A plus B. Because this is a negative displacement, you need to find its magnitude and you have to take its value positive.
Yes.
Right? So if I had to find A plus B, let us first find what is A. Can I find A by doing the same integration, but my limit should be from 0 to 2?
Yes, sir.
So let us first find A by putting the limit from 0 to 2. T dt from 0 to 2 minus t square by 2 dt from 0 to 2. Can you calculate this one?
Two by 3.
By 6. Yes. So it is 2 by 3. So if I know A is 2 by 3, A minus B is minus 8 by 3, can I find what is A plus B? Can you find what is B now? 2 by 3 plus
10 by
8 by 3, 10 by 3. So what is A plus B?
4. Sir, 4.
4 meter. So that
Sir.
should be the answer of your question. Yes, tell me.
Sir,
Sir.
we can do it V equals, and
Sir.
then we can integrate from with
Yes,
V
also
equals
you
to
can
2,
do that.
T equals
Also you
4.
can do it like this. You can
If we do,
yes. You can integrate it from 0 to 2 and then integrate it from 2 to 4, and you will find the value to be minus 10 by 3. You take this value to be plus and
track
divide.
both the values.
Yes, you can also only add their derivatives. So I think that we have understood how to deal with this non-uniform acceleration and use the general equations of motion to solve those. Right. So today we will end our class here only. But what I have for you are few questions on motion under gravity as well as the motion with non-uniform acceleration. As you can see that you have not done this one. We have not done this one. So you try these two questions as your homework.